Welcome back to C23 Classroom channel. So I would like to discuss with you to share about the formation of von Karman equation. So this von Karman equation is very important because by using this equation we could get the shear stress, and then we could complete our calculation about boundary layer to get coefficient of drag and lift and drag force. Von Karman equation is introduced by von Karman between 1881 to 1963, and he used the idea of conservation of momentum. So the idea is very simple. For example, we have a thin plate here and we have a free stream velocity here. This free stream velocity flow on the thin flat plate here, the no slip condition occur and create the velocity profile like this. So we imagine that the momentum in the inlet is actually not equal to the momentum at the outlet, because at the outlet the momentum, a part of the momentum is lost. So the basic idea is momentum inlet need to be equal to momentum outlet. So the momentum can be calculated by multiplying the value of mass and velocity. So mass can be calculated by multiplying rho and volume. It's already discussed in previous video. Then please draw a diagram like this. So this is the velocity profile at the outlet. We imagine that there are a deficit of momentum at this area. So we need to calculate what is the momentum deficit on this area. So first we imagine that we have a very small area, rectangular area here. So this is the shaded area. We assume that the thickness of this area is equal to dy. Then we assume that the distance here is equal to capital U minus U. It is because this is the free stream velocity length, which is capital U, and this is the local velocity of this molecule. So the distance here or the difference here can be stated as capital U minus U. So the mass for the shaded area is rho and volume, and rho is the density. Volume can be calculated by multiplying the length, capital U minus U, the thickness dy here, and the width. At this situation, we assume that the width is equal to b. Then the deficit momentum for the shaded area here can be calculated by mass times velocity. So the mass is equal to this one, rho u minus u b dy, and velocity here is equal to u, because this is the velocity that molecule travel from here to here. Then to get the total amount of deficit momentum, we integrate the value here. We integrate the small d here, so we could get the total deficit momentum. So we could write the previous equation become rho b integral from 0 to delta u capital U minus u and dy. Then we rearrange the terms here by adding u square. So we could put u square over u square. We bring the over u square here. So and then we could simplify this term into u over u, 1 minus u over u. So this equation must look familiar for you to you, because this equation is actually equal to momentum thickness, theta. So To simplify this one, we differentiate the d here with x. So we have d over dx is equal to rho b u square d theta dx. And then we name this equation as equation 2. So another idea about the deficit of momentum is it is because of the friction. So as we know previously, force is equal to tau A, and then we could say that deficit momentum is actually shear stress times dA, which is A here is the dx, the length of flat plate in x-axis, times its width B. Then we could simplify this term into dd over dx equal tau b. And we state this expression as equation 3. From equation 2 and 3, we could equalize both of them, and we could say that dd dx is rho b u square d theta dx equal to tau b. Then we can cancel out the value of b here. We could have tau is equal to rho u square d theta dx. This term is known as von Karman equation. Another thing that you need to know before we could uh, do the calculation is another method to know or to calculate the value of shear stress is by having Newton's law of viscosity. The equation is tau is equal to mu du over dy at y equal to 0. So mu here is the dynamic viscosity, tau is the shear stress, and du dy is the velocity profile, means the changes of u, the local velocity, to the distance of y. And then we need to take value of du dy at y equal to 0. So it is because the shear stress will occur in maximum value at y equal to 0, because at equal to 0, it's in no slip condition, means the resistance is the highest value. Thank you for watching. Please subscribe this channel, C23 Classroom channel. Thank you for watching.